Hello friends, welcome back. So today we are going to learn about the linear programming models in operations management. What is linear programming? Before understanding linear programming, we have certain basic assumptions about the business which we should take into consideration. We assume that in the real world, every business organization is looking for maximizing the profits, and even if not for profit organization look for increasing the surplus, or in other words they are look for the minimizing the cost. But at the same time, when you are maximizing the profit or minimizing the cost, you also consider that is if your objective, but this work is objectives are being constrained by certain factors. Now what are those factors which constrain you? The constraints are being given by the various factors of production or marketing or any operations. Maybe if limited because of technology is like that, or maybe it's limited because we don't have the proper human resource available or maximum quantity of human resource available, or may also be we don't have financial resources. So linear programming is based on these basic assumptions that we can maximize the profit and gains because there is a linear relationship which exists between the various constraints. If you increase the resources, that will lead to the maximizing the output, and that will lead to increasing the profits. So that means there is a linear relationship which exists among the various products. So what we consider in the linear programming model is, first, that we want to maximize or minimize the profits. Second, we have a constraints. Third, we have a various alternatives available, means various combinations are available, permutation and combinations which can be applied to maximizing or minimizing the objective. So but one thing is very important, that we assume all equations are having a linear in nature. That means change in one will lead to change in other, and we also know what is the amount of change which is going to happen because of change in another variable. So that is the whole crux of linear programming models. So let's understand what are the various steps in the linear programming. So linear programming model involves basically three steps. Firstly, we try to formulate a problem. That means we convert that problem into a mathematical model, and then we try to solve the problem with the help of various methods which are available. Basically we generally use two methods. One is graphical method, other is the simplex method. But at the same time we can use together combination of that is we can use in the Excel function, that is a solver function can be used in Microsoft Excel. That is a very useful tool which we can use. After doing that, we interpret the results, and we can also carry out sensitivity analysis. Means sensitivity analysis is done post solution, because we want to check it out whether the solution which we have gained, if there is a change in the inputs, what will happen, or if there is a change in my objective function, what will happen. So sensitivity analysis will, whether my solution will change because of that or not, sensitivity analysis will help you out for that particular reasons. Let me give you some basic assumptions about the linear programming model, because these assumptions will guide us in solving our problem in the model as well as formulating the problem. So first assumption of the linear programming model is certainty. So for certainty means we are assuming that we know already in advance what is my objective and what is the contribution of each factor. Means let's say if I am saying in example that you are producing two products, one is chair and other is a table. So table, how much profit you are going to earn from the per unit from the table and per unit from the chair, that is already fixed. So there is nothing is going to change. And same way, how much quantity of labor is available with me, how much quantity of polishing people is available with me, all these things are certain and it's fixed. So that is the first basic assumption of linear programming model. And second, a basic assumption of the linear programming model is proportionality. Now what is proportionality? So it means, as I said in the beginning, the change which is going to happen. The relationship exists between the objective function and the constraint. With the change in the constraint, there will be lead to a change in the objective function. That means if there is a change in my availability of labor, that will change my profits which are going to be incurred from my business. Third basic assumption of the linear programming is additivity. Now what is additivity? It means total of all activities equal to the sum of the individual activities which are going to be performed. Means we already know that this kind of additions which are going to happen onto the various resources, that will lead to production of one complete unit which we are going to have. So there is not going to be any kind of anomalies which are going to happen, that generally people say when 1 plus 1 is equal to 2, but people say, oh, there is a synergy effect that 1 plus 1 is going to 11. That kind of synergy effects are not going to be happen in our in our thinking. That is why we assume only 1 plus 1 will lead to 2 only, not 3 or 5 or 11. So fourth assumption we have is about divisibility. Means we can divide the resources up to any extent, and answer is not required to be in the whole number. It can be in fraction. Last but not the least, most important assumption of the linear programming model is non-negativity. Means we cannot produce anything in negative. It will be always a some positive answer. Answer can be 0 or 1 or it can be in fraction, but it should be there, but it cannot be negative. So let's take an example. I'm taking example of Flair Furniture Company, which is going to produce 2 products, chair and table, and decision is how many tables and chairs we should make in each month, and objective of us is to maximize the profit. So the information which we have gained from the company as an input is that the profit contribution of the table is $7 per unit and chair is $5 per chair, and total carpentry hour which is available with us is 2400 hours, and for painting is 1000 hours. Each chair require 4 hours of carpentry and each table require 3 hours of carpentry, and same way for painting, table require 2 hours and chair require 1 hour. We have some other limitation also. We cannot make more than 450 chairs because of the total material available with us, and we should at least make 100 tables to make a combination of chairs and table, and looking into the market demand for the tables. So the second step, as I said, would be after obtaining the information is to formulate the problem. So how we are going to formulate the problem into mathematical model? So what is our decision which we have to take? Our decision is we have to identify how many number of tables or chairs we are going to make. So we are assuming T is equal to number of tables to be made and C is equal to number of chairs to be made. And objective is we want to maximize our profit. So how we are going to maximize? Each unit of profit which you are going to make from each table is going to multiply, and same way each unit of profit we are going to make from chair is going to be multiplied by number of chairs. So as we assume number of table and chair is T and C, so our objective function will be maximize Z, that is maximizing our profit is 7T plus 5C. So the constraint which we are having now to meet this objective is we having a 24 hours of carpentry available, that is the maximum hours which are available, and we said one particular table require 3 hours and 4 hours are required for the each chair. So our next equation would be 3T plus 4C, and we have a maximum availability of hours is 2400. That's why we are using a sign less than or equal to 2400 hours. And second constraint which we have is about the painting. So painting time maximum available with us is 1000 hours, and so that's why our equation would be 2T plus 1C, that is less than equal to 1000 hours, because we require 2 hours of painting for table and 1 hour for the chair. The other constraint which we had related to the number of chairs, that is which we can maximum go for. So that's what our constraint would be. Number of chairs should be less than or equal to, the C should be less than equal to 450, and another constraint which we had is about the tables, that is at least 100 tables we have to make. So it means our tables will be t should be more than equal to 100. But remember friends, I said one of the key objective of our linear programming model and our assumption is our solution cannot be negative. That's where we are going to have another constraint, that is non-negativity constraint, that t, the number of tables going to be produced, should be either more than equal to 0 and number of chairs would be more than equal to 0. That means at least there would be 0 or plus, but it cannot be negative production which is going to happen -1 or -2 tables. That is not going to happen. We are not going to destroy anything. So let's summarize the model which we have gained. So model which we have gained is maximizing our objective, that is 7t plus 5c is our profit, and we have constraint now 3t plus 4c less than equal to 24 hour, that is carpentry hour, 2t plus 1c less than equal to 1000, that is painting hours, and c, that is chairs, would be less than 450, that is maximum chairs, and t more than equal to 100, that's a minimum number of table which we are going to produce, and t and c are is more than equal to 0, that's a non-negativity constraint. Friends, one thing which you have to remember, that even in this constraint, if we don't write t is more than equal to 0, that will not going to have any impact, because we already have written t is more than equal to 100. Thank you friends.